Hello, Randy, K7AGE. While working on my BIT X40, I had the need for a simple audio sine wave generator. So instead of building one myself, I thought I would look around on eBay to see what I could find. I found this little function generator kit based on the XR2206 IC, and it makes sine wave, triangle, and square waves from 1 hertz to 1 megahertz. It includes a case. It was $7.29 plus $1.85 for shipping. So for a little over $9, I got this little kit. It took 19 days to get it here, and I bought this from Alice1101983. And one of the reasons I chose Alice is that I watch a lot of Julian Ilett's videos where he buys an awful lot of stuff from China, and he's had fairly good luck with things. So,
good morning all, lots of post, so it's post bag. Okay, let's start with this one. What could it be? Hopefully no more late night eBay shopping.
Let's look at the package and see what we got. So there's a package, one of these just little simple plastic envelopes from China. Everything's in a bag. So let's open this up and see what we got. Some instructions. Looks like all the acrylic pieces for the case that are all kind of cut out. And we got a whole bag of parts and knobs and things, and capacitors, some hardware. Where's the IC? Oh, here it is. Integrated circuit. And the so-called directions. So we got a component layout, a parts table. Here we go. The welding installation considerations. Components are welded from the front of the board. Welding the IC socket, debugging steps, and using the steps, and a little schematic. So I think it's time to warm up the soldering iron. And wrapped up in all the case pieces is the printed circuit board. So it's solder mask, silk screen, all the parts are called out, plated through holes, and I think that'll work out very nicely. So start putting the parts on. So the welding installation considerations are basically to start with the low profile components and work up to the taller ones. So I've placed R1 here on the board, and it's a brown, black, black, brown. I like the old colors, brown, black, red. So it's a 1, 2 zeros, and then a multiplier of 10. So that's 100, it's 100 times 10 is 1K. So I'm going to place all the resistors on the board and then solder them. R3 and R5 and R6 are all 5.1K. R4 is a 330 ohm resistor, orange, orange, black. Well, unfortunately, I didn't have the camera running while I soldered all the resistors, but I have capacitors now. Pick these up and try and read the number off them. This is a 222, so that is 2,200 picofarad, and that is C7. That goes there. And reach underneath the board and just bend the leads apart. Let's pick this one up. And this one's 473, so this is 47,000 picofarads. And 473 is C6, so that goes below C7. This one is 101, 100 picofarads, C8, and that's up above. Goes right in there. 105 is 1 microfarad. This is C5, and that goes the bottom one of the group here. And the last of these little ceramics, this is a 104, and this is 0.1 microfarad, and this is C2, and that goes over here. And I'm ready to turn it over and solder those capacitors. Okay, ready to solder the capacitors. I have my trusty .031 6337 rosin core solder in my finger here. And I don't like the looks of that one. And the trick, what you try and do is put the iron on one side of the lead and the solder on the other side of the pad and kind of let it flow in. And when you kind of see it fill in the hole of the pad, you should have enough. You don't want to get too much solder and cause a solder bridge. This board looks like it has solder masking on it, but there's not a lot of room between the trace and, say, the ground plane here. Now I come in with my side cutters and cut these leads. I try and grab them so they don't go flying around the room. And kind of keep hold of them. I don't like them falling in the carpet. So I have 3 electrolytic capacitors to mount on the board. This is a 100 microfarad capacitor, and the white band here is the negative. Got little dash signs. So this is 100 microfarads. This is C1, and that goes in up here, and you can see the board is marked here for the minus side. So that'll go in with the white in that area. Then there's 2 of these 10 microfarad capacitors. So that's C3 and C4. So again, you can see the striped area on the board. So that's where the minus sign, or the minus side of the capacitor, will go. Push that down in there, and the holes aren't quite right, so the capacitor doesn't go down to the board, but that's okay. And here's the other 10 microfarad capacitor, and it wants the negative lead to the left. And push that down, just snug to the board and bend the leads. And now solder in the electrolytic capacitors. There's one lead over here. Okay, there we go. And come back in and cut off all the leads. Okay, the next thing I'm going to solder on is the IC socket. You always want to be aware of the polarity, so you can see the little U-shaped mark on the silk screen and a little corresponding U-shape or a little dip here on the top. So you want to make sure you get those lined up, because this is pin 1 in the top left-hand corner. That just drops in there. And I'm just going to put a little tape on there to hold that while I solder it so it doesn't come out. Okay, I'm ready to start on the IC socket. I'm just kind of pressing that on the top side there. And it's just a little touch loose. I'm just going to put a little bit of solder on this pin here, reach underneath, and heat that up and push it up. And that'll hold it there. I'll just solder the corner. This is pin 1 here. You can see the little square pad. And solder this corner. And then just work my way down all the other pins here. Okay, that's the IC socket soldered in. Okay, the next thing, there's a group of header pins. There's that one there of 10. And you want to have the short pins through the board. This is a group of 4, and these don't matter which way they go on. So I think they'll be all right. I think they'll stay in the board while I flip it over. Well, as soon as I turned the board over, the 10-pin header fell right out on the floor. So I used a little bit of the blue tape to hold it in. So I'm soldered in one pin here, and I'm just going to heat that up and push it from the bottom side or from the top side of the board so that all the pins seat fully. And again, it's about like soldering the IC. This may take a little more heat, a little larger pins. Again, you don't want to linger too long because it's just a piece of plastic on the other side that's holding those. And you don't want to get too much solder in there. And finishing up with the 4-pin header. Next couple parts are the DC power connector. It goes there. That's pretty loose. Tape will help hold that there while I get it soldered. And the other is the output connector. So this is a little screw-down terminal strip, so you want to have the terminal strips facing out. So your wires would come off the side of the board here. And that fits snug in the board, so more soldering. And solder in the power socket. Turn the heat up on my iron a little bit with these big lugs. It helps. I think it's about 750 degrees. Here's the 3 pins for the output connector. And that's the 3rd pin. Okay, time for the 3 potentiometers. This one is labeled, you can see in here, B1, then 04. So that's the 100,000 ohm, 100K, and that's R8, which is this one. Then the other 2 are marked B503. So that's 50 with 3 zeros, so that's 50K. And these lugs here on the side really help to hold the resistors in the board. And so there's 2 of these, it's R2 and R7. That's the only place left. So get the leads out through the holes here. I'm going to make sure these are all down flat on the board, ready to solder them. So here's the 3 terminals for each of the potentiometers, and these 2 large ones are those mounting bracket things, so I'll take a fair amount of solder to get those in. And I've checked the pots to make sure they're down flush on the board. Otherwise, with all these connections, it'd be hard to loosen them up and move things around. So that's 1 pot soldered. And finishing up with the 3rd pot, soldering in the 3 terminals. So it looks like it's pretty much done. All the parts are on the board. Okay, so I got everything mounted. Just a quick look over. Next thing to do is to put the integrated circuit in. So again, when you're working with the ICs, you got to pay attention to the polarity. So here's the U. And the pins quite often they're spread a little wide. So what you can do is just hold it on a flat surface and just kind of bend those a little bit to make them straight. You can see those now are more parallel. So then hopefully it'll fit there in the socket. And all the pins are inside there, and now I can just push it down. It slid right in. And you can look on the end and check around to make sure the pins are down in the socket. They're not sticking out, and they're not bent underneath the IC. Other thing I'm going to do is put these jumpers on. Doesn't really matter where now. I just don't want to lose them, so I'm going to slide those on. Okay, now onto the case. So I've taken all these pieces of plastic and peeled off all the protective bits and pieces. This is the top, and it has Looks like it's been etched with some writing. It's got some labels on there, a little hard maybe to see. So I know that's the top. And of course, this is the bottom. There's two end pieces. That's probably where the power, and this one's for the I/O connector, and then two bottom pieces. Now, I've seen videos on YouTube where people have gotten this far and then they struggle with the case. I'm not sure I can really know what's going on, so I'm just going to fool around with it, and hopefully when we come back, have it together. There's not much to go by. It's just a picture here, and there's a bunch of screws. The exercise is left to this student. So I think I figured out the trick. You take the short screws and the nuts, and you just screw those into each of the 4 holes in the corners. Then this will just sit on the base plate. Then all the plastic pieces fit in the notches all the way around. And that power connector's got to stick down through there. So you just kind of work all these things together. And then the top fits down over that. And then you have to kind of wiggle the pins around and such to get these things to seat. So it's a little bit of trial and error. So keep working on it and force it down. You may have to kind of jiggle the power and the I/O connector. And then these screws go through, and they just screw into the bottom piece. There's no nut. I think they just, I'm hoping. Yeah. So I think that's kind of how you put it together. Okay, I have it together, so I'm going to put the knobs on. I'm turning all the controls counterclockwise. Put the knobs on. They just push on. There we go. I think we're done. So here's the power connector. You get the part on the board, but you don't get the cable end. So this is one I've made up for my Arduino Uno, a little computer board. So it takes a 9-volt battery, and that fits in there. So, and it's going to operate between 9 and 12 volts. It does say supply more than 12 volts. The output waveform is unstable. Okay, so getting ready to fire this up. Just point out a couple of things here. Of course, this is the power connector. This jumper here, there's 5 positions to select the frequency range. So 1 to 10 hertz, 10 to 100 hertz, 100 to 3 kilohertz, 3 kilohertz to 65 kilohertz, and 65 kilohertz to 1 megahertz. So I have it in the 100 to 3 kilohertz. And the jumper up here, the selects either a triangle or sine wave for this output. And the square wave is on the middle jumper, or middle position, and ground is on here. So I'm going to hook up my scope probe and plug in the battery and take a look at this. Okay, so I have it, the scope probe hooked up to the sine wave output, the jumper in the sine wave position. And one of the first things I immediately notice is that the level control works backwards. As I turn it clockwise, it reduces. So the PC board layout is backwards on that. So I increase it up, you can start to see distortion on the positive peak before the negative peak. And the frequency knobs, that range, that's the highest. And that's the lowest there. Okay, so I have the jumper in the triangle output. And so you have to turn the level down to get the triangle waves. But, yeah, that works. Okay, I have it on the square wave output. It's a higher amplitude signal. Let me drop the scope down. The level control, I'm turning it now, has no effect. So the square wave is a fixed amplitude, and it looks to be about 4 volts. And, of course, the frequency tracks the other waveforms. So I have taken this all apart because I wanted to fix the level control so it increases when you turn it clockwise. So I've cut the lugs on each end of the pot right at the circuit board, removed the piece of lug going through the circuit board, bent the lugs up, and then have the two wires here to cross connect the end lugs of the pot. So now as I turn it clockwise, the level increases. So this brings me to the end of this video. I hope you enjoyed it. It's maybe a little bit long, but I wanted to show a lot of the steps of building a kit. This is a fairly simple kit, probably be good for a beginner, and fairly straightforward, nothing complicated, all through hole. You end up with a nice little sine, triangle, square wave generator that runs off a battery if you need a tone for something, or just a little kit to experiment with. So anyway, thanks for watching. This is Randy, K7AGE, and if you like this video, please give it a thumbs up, and you can follow me on Twitter at K7AGE and on Google Plus at +K7AGE. Thanks for watching. 73, Randy.